Welcome to section 3.3, Proving Lines Are Parallel. The other day we talked about if we had two lines, let's say line M and line N, and we had a third line that cut across them. We'll call that line L. Line L was being referred to as a transversal. And that we had 8 different angles that were formed. We had angle 1, 2, 3, 4, 5, 6, 7, and 8. Then certain angles had certain relationships or were placed in certain positions. And we said that angles 1 and 5 were corresponding. Let me just list them. We had corresponding angles. We had alternate interior. Alternate exterior. And we had same side interior. So for instance, corresponding had 4 pairs. I could say one pair might be angles 2 and 6 were corresponding. For alternate interior, they had to be on opposite sides of the transversal and in the interior. So that would be 4 and 6. It could also be 5 and 3. Okay. Alternate exterior. Those were on opposite sides of the transversal and in the exterior. So we would have 1 and 7. And you could also have 2 and 8. For same side interior, that would be those interior angles that are on the same side of the transversal. So you're looking at 4 and 5, or you could also say 3 and 6. Now, we also mentioned what happens when M is actually parallel to N. So when M is parallel to N, we have M parallel to N, then we know that those angle pairs exhibit special properties. So for instance, all corresponding angles are congruent, all alternate interior angles are congruent, alternate exterior angles are all congruent, and same side interior angles are supplementary. But of course, this only existed when the lines were parallel. We had to know that they were parallel first. So today's video is going to talk about the converses of those statements. Remember, one statement was if the lines were parallel, then the corresponding angles were congruent. So think about what is the converse of that statement. Remember, converse is if Q, then P. We now switch the hypothesis with the conclusion. So if the corresponding angles are congruent, then the lines are parallel. And remember, corresponding angles, you have 1 and 5. You have 2 and 6. 4 and 8. And 3 and 7. So the hypothesis is, if angle 1 is congruent to angle 5, then L is parallel to M. Let's apply that same thing to the converse of the alternate interior angles. If the alternate interior angles, if we know that they are going to be congruent, then we can state that the lines are parallel. So we better mark in congruent. And an example would be, if 4 is congruent to 5, well, if your alternate interior angles are congruent, then that implies that your lines must be parallel. So if I'm trying to show that lines are parallel, I need to know something about those angles. So by now you're probably catching on the pattern. What do we need to know about alternate exterior angles to say that the lines are parallel? Well, they need to be congruent. An example would be if 1 is congruent to 8, then we know L is parallel to M. And finally, if I want to know that L is parallel to M, or I'm trying to prove that lines are parallel, what do I need to know about the same side interior angles first? That they are supplementary. So an example would be if angles 2 and 8 are supplementary, then L is parallel to M. So to wrap up, the key thing from this lesson is if you know corresponding angles are congruent, or if alternate interior angles are congruent, alternate exterior congruent, or same side interior are supplementary, any one of these 4 facts proves lines are parallel. So if you're trying to show lines are parallel, you need to know something about their angles first.